Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we will do some questions on complex numbers. But before that, let us have a look on this result. That is, if we have a complex number z equal to x plus iota y, then z conjugate is equal to x minus iota y. Modulus of z is equal to square root of real part square plus imaginary part square, that is x square plus y square. Similarly, modulus of z conjugate is equal to square root of real part square plus imaginary part square, that is x square plus minus y square, which is further equal to x square plus y square, that is equal to mod of z. Thus modulus of z conjugate is equal to modulus of z. Now let us do some questions on complex numbers. Here is the question number 14. Find the real number x and y if x minus iota y into 3 plus 5 iota is the conjugate of minus 6 minus 24 iota. Let us do this question. Here it is given that x minus iota y into 3 plus 5 iota is equal to conjugate of minus 6 minus 24 iota. Okay, we have to find x and y. So for that, we have to evaluate this. We will multiply these two complex numbers and we get x into 3, that is equal to 3x. Then x into 5 iota, so we get 5x iota. Then it is iota y into 3, it's minus times, so we get minus 3y iota. Then again minus times, it is 5y iota square, as iota into iota is iota square, that is equal to a conjugate of minus 6 minus 24 iota is minus 6 plus 24 iota, because in conjugate the sign of imaginary part get changed. Okay, so in this case it was minus 24 and it is changed to plus 24 iota. Okay, or we can write 3x plus 5 times x minus 3y, take iota common, then we have iota square is minus 1, so minus minus is plus, so we get plus 5y, that is equal to minus 6 plus 24 iota. Or we can write it as 3x plus 5y. 3x plus 5y, it's a real part of this complex number. Then we have plus 5x minus 3y, and this is imaginary part, is equal to minus 6 plus 24 iota. Now equating real and imaginary parts on both sides, we get 3x plus 5y, that is real part, is equal to real part of this side, that is minus 6. Name this as equation first. Also we have 5x imaginary part minus 5x minus 3y is equal to 24. This is equation second. Now to find x and y, we have to solve these two equations. Okay, so let us solve these equations by elimination method. For that we will multiply equation first by 5 and equation second by 3, so we get, multiplying equation first by 5 and equation second by 3, we get 15x plus 25y is equal to minus 30. Name this as equation third. Now we multiply this equation second by 3, so we get 15x minus 9y is equal to, it is 3 fourths are 12, 2 are 6 and 1 is 7, so it is 72. We name this equation as equation 4. Now subtracting equation 4 from equation 3rd, so we get 15 minus 15, 0. It is 25y minus times minus 9y, so it is 25 plus 9, that is equal to 34y, which is further equal to, it is minus 30 minus 72, so it becomes minus 102. Okay, or we can write y is equal to minus 102 divided by 34. So that is equal to 34 ones are, 34 threes are, so it is minus 3. Thus we get y is equal to minus 3. We use y is equal to minus 3 in equation first, we get x. So we can write 3x plus 5 times, instead of y we write minus 3 equal to minus 6, or 3x minus 15 is equal to minus 6, or 3x is equal to minus 6 plus 15, that is equal to 9. Thus we can write 3x is equal to 9, or x is equal to 9 by 3, which further imply x is equal to 3 ones are 3 threes are 9, so we get x is equal to 3. Thus y is equal to minus 3 and x is equal to 3. This completes the question. Now let us take one more question, that is, if x plus iota y whole cube is equal to u plus iota v, then we have to show that u by x plus v by y is equal to 4 times x square minus y square. Let us prove this result. Here it is given that x plus iota y whole cube is equal to u plus iota v, and we have to prove that u by x plus v by y is equal to 4 times x square minus y square. Okay, now we will take this, that is x plus iota y whole cube is equal to u plus iota v. Okay, now it is of the form a plus b whole cube, so that is equal to a cube, that's x cube plus iota y cube plus 3 times a square, that's x square, into b, that's iota y, plus 3 times ab square, that is x, into iota y square, that is equal to u plus iota v, or we can write it as x cube plus iota cube. Iota cube is equal to minus iota, so here we can write minus times iota y cube plus 3x square y iota. Then we have, here it is 3x iota square is minus 1, so we can write minus, so we get 3x y square. 3x y square is equal to u plus iota v. Now we separate real parts and imaginary parts. Here real part is x cube minus 3x square y, sorry, it is 3x y square, 3xy square. Then imaginary part is, it is plus 3x square y, 3x square y minus y cube iota is equal to u plus iota v. Now equating real part and imaginary parts, a real part is x cube minus 3x y square on LHS, and on RHS real part is u. Similarly, imaginary part is 3x square y minus y cube on LHS, and on RHS imaginary part is v. So we have, on equating the two sides, or on equating the real part and imaginary part, we get x cube minus 3x y square is equal to u. Okay, and 3x square y minus y cube is equal to v. Now take x common, so we can write x into x square minus 3y square is equal to u. Now here take y common, so we get y 3x square minus y square is equal to v, or dividing both sides by x to this equation, so we get x square minus 3y square is equal to u by x. Now dividing both sides by y to this equation, we get 3x square minus y square is equal to v by y. Now on adding these two equations, we get u by x plus v by y is equal to x square minus 3y square plus 3x square minus y square. That is further equal to, it's x square plus 3x square, that is equal to 4x square minus 3y square minus y square is minus 4y square. Now we can take 4 common, so we get u by x plus v by y is equal to 4 times x square minus y square. That proves the result. Now we have one more question, that is, if alpha and beta are different complex numbers with modulus of beta equal to 1, then find modulus of beta minus alpha divided by 1 minus alpha conjugate beta. Let us find this result. For complex numbers alpha and beta, we have to find modulus of beta minus alpha divided by 1 minus alpha conjugate beta, while modulus of beta is equal to 1. So since modulus of beta is equal to 1, that implies mod of beta is equal to 1. That implies mod of beta conjugate is also equal to 1. Now we will find this. For that, we can write it as this beta minus alpha divided by 1 minus alpha conjugate into beta. We multiply this modulus with mod of beta conjugate, beta minus alpha divided by 1 minus alpha conjugate beta. Since modulus of beta conjugate is equal to 1, so by multiplying modulus of beta conjugate to this modulus, it remains unchanged. Okay. or we can write it as, this is further equal to, it is mod of beta conjugate beta, by taking the same modulus for this complex number and this complex number. So we can write beta beta conjugate minus beta conjugate alpha, or alpha beta conjugate divided by 1 minus alpha conjugate beta. That is further equal to, it's mod of beta beta conjugate is equal to mod of beta square minus alpha beta conjugate divided by 1 minus alpha conjugate beta. That is further equal to, now since beta modulus of beta is equal to 1, so modulus of beta square is equal to 1 square, that is equal to 1. So we can write 1 minus alpha beta conjugate divided by 1 minus alpha conjugate beta. Now in numerator we have 1 minus alpha beta conjugate, and in denominator we have 1 minus alpha conjugate beta. So we take conjugate either to numerator or to denominator to make them identical. For that, you can write it as, it is mod of 1 minus alpha beta conjugate divided by mod of 1 minus alpha conjugate beta. Now in numerator we take conjugate, and by taking this conjugate, its value remains unchanged because mod of z is equal to mod of z conjugate. So that is further equal to, it is 1 minus alpha conjugate minus beta conjugate conjugate, that is equal to, sorry, it is into beta conjugate conjugate is beta, okay, divided by mod of 1 minus alpha conjugate beta. Now this in numerator and denominator they are same, so this is equal to 1. Thus we get the value of beta minus alpha divided by 1 minus alpha conjugate beta equal to 1. This completes the question. Now in my next lecture we will do some more questions on this topic. Till then, take care of yourself. Thank you.